Sketch the graph of the rational function. The first thing we always want is the domain of our function. Any function that you're graphing, you want to know the domain. So for that, we're going to factor our function. So the numerator is a difference of squares. That's x minus 3 and x plus 3. In the denominator, we factor that, and we get x minus 3 times x plus 1. And for our domain, we know we can't divide by 0. Okay, so x cannot be 3 because of this factor here, and x cannot be negative 1 because of this factor here. And so our domain is the set of all real numbers such that x is not equal to 3 and x is not equal to negative 1. The next thing we want to do for rational functions is reduce the fraction. So to reduce the fraction, we look at our factored form and we cancel any common factors, which in this case is the x minus 3. That can cancel. So our reduced form, I'll call that little r of x, we get x plus 3 over x plus 1. Now we're going to use this reduced form in a lot of different ways, so we like having that early on. Okay, the next thing we're going to do is to find wholes. Okay, and wholes we find by looking at what values of x are we allowed to plug into the reduced form that we were not allowed to plug into the original form. And because we canceled out this x minus 3, that means we would be able to plug 3 into this reduced form. There's no problems there. Okay, and so because of that, and we're not allowed to plug it into the original, that means we have a whole when x is equal to 3. Okay, 3. Now to get the y value, I need to plug that 3 into the reduced form. So r of 3 is 3 plus 3 over 3 plus 1, which is 6/4 or 3/2. Okay, so that's the y coordinate of the whole. That's the only value of x that works in the reduced form that doesn't work in the original. So that's the only whole. Next, we want vertical asymptotes. Vertical asymptotes, all we need to do is look at the zeros of the denominator of the reduced form. So again, looking at the reduced form, the denominator has a 0 of x equals negative 1. So that is our vertical asymptote. Next, we want intercepts. So we have y-intercepts. To get the y-intercept, you plug 0 in to the reduced form. So r of 0 is 3 over 1, which is 3. Okay, so our y-intercept is at the point 0, 3. For our x-intercepts, we set the numerator of our reduced form equal to 0. So if we set x plus 3 equal to 0, we get x equals negative 3. So the x-intercept is negative 3, 0. Next, we want horizontal asymptotes. Horizontal asymptotes. Asymptote. So for our horizontal asymptote, we look at the leading term, and we again just have to look at our reduced form. So our reduced form here, we've got an x on top and an x on bottom. Those are the leading terms. Those have the same degree, and that means that the horizontal asymptote is just the leading coefficients, which in both cases here is just 1. So our horizontal asymptote is y equals 1 over 1, which is just 1. All right, and now we are ready to sketch. So we're going to draw everything that we just found and then connect it all. So start with our holes. We have a hole at 3 3/2. Let's go ahead and draw out our scale here. And draw our hole. So we've got our hole at 3 3/2. And so 1, 2, 3, and then 3 halves is about 1.5. Right here we have a hole. So there's our hole. Next is we've got our vertical asymptote at x equals -1. So there's our vertical asymptote. Next, we have our intercepts. Okay, so our y-intercept is at 0, 3. So 0, 3. There's our y-intercept. And our x-intercept is at -3, 0. So right there. And finally, our horizontal asymptote is up at y equals 1. So we'll draw our horizontal asymptote. Okay, and then we need to draw. And really, there's nothing special happening here because we have to go pass through these points and holes and follow the asymptotes. So there's really only one option here. Follow the horizontal asymptote, pass through the point, okay, and we come down and follow our vertical asymptote. I should say we do know it passes through the point instead of bouncing off the point because that came from x plus 3, which has an exponent of 1, which is odd. So that tells us it's going to pass through. And then we've got to go through this point. So we have to start up here. So if we start down here, we would cross the x-axis. So start up here. Pass through, hit our hole, keep going, and follow the horizontal asymptote. So there's our graph of our rational function.